my interaction, I chose to research Compton scatter. I felt like this is very important because us as technologists were the ones that are mostly affected by scatter radiation. When you use a higher KVP greater than 30, you increase the amount of Compton scatter that's going to be created. With that being said, even if you're doing a regular sized patient, you're using most likely more than 30 kVp, so you're having scatter radiation. When you go into the room after waiting a certain amount of minutes, seconds for the scatter to dissipate, it's going right into you because us technologists, even though Lynn tells us to, we don't wait for it to dissipate. Compton scatter was discovered by Arthur Holly Compton, who also was awarded a Nobel Peace Prize for his discovery of Compton scatter in 1927. Compton scatter is one of the main photon interactions. This is when scatter radiates off of a given material. When an interaction happens between an X-ray or a gamma ray, it happens within a free electron or a free atom or a loosely bound valence shell electron, which is an outer shell electron. This results in the incident photon scattering, which changes direction other than directed. When it's directed towards the patient, it changes direction. It's not absorbed. This is known as recoil. The Compton effect is a partial absorption, and when it's partially absorbed, it loses the energy that it had. Compton scatter is directly proportional to the number of outer shell electrons and the electron density. Also, it is proportional to the physical density, so the given material that it's trying to penetrate and is not absorbed by, which scatters off. Photon energy is inversely proportional to scatter or Compton scatter. Also, Compton scatter does not depend on the atomic number. Some other interactions do, such as photoelectric absorption and pair production. Compton scatter is more dependent on the number of electrons per gram of absorbing material. When Compton scatter happens, it delivers misinformation to the IR, which will create fog on our image receptor, which will make the image not clear. Also, scatter will increase the overall darkness of our film. Compton scatter interacts depending on the absorbing density. So if it's trying to absorb through muscle, blood, or solid organs, that's when the greatest amount of scatter is going to happen. When it's going through bone, it's not going to scatter as much because more of the X-ray photons are going to be absorbed. So this is why I thought this one was pretty important, because it shows like how it can affect your X-ray and how it affects us as technologists.